Physics. What is it? It's more than just a high school class we take. We can apply its concepts to nearly everything on this planet and throughout the universe. Physics is a science that involves matter and its interaction with energy and forces. Physics helps us explain how we can drive a car, or throw a baseball, or even move our bodies. Specifically, how we run. In this modern age we live in, world records continue to be broken as athletes stretch their bodies to the limit to turn out fast times. And surprisingly, we use and analyze the physics of running to pinpoint key movements that help us enable and, yes, enhance our body's running performance. Studying the physics of running can teach us more about how and why we move our bodies the way we do. But within recent years, many have begun to credit a new form of running as a solution to chronic running injuries. It's been praised as the best way to run, and that's a pretty prestigious title. Well, what is it? Barefoot running. Scientists claim that this new craze puts less impact on the body when we run, because it forces us to run the way our bodies were meant to run. But what does this all mean? I'll show you in a minute, but before we get to analyzing the physics behind barefoot running, we need to review a few key concepts. There are many different aspects in which we evaluate the physics of running, but we'll touch on a few essential pieces. The most basic things we should know about running in physics are velocities and accelerations. We use the term pace quite often, but this simply refers to velocity, or average speed. We calculate your average velocity by dividing the distance covered by the period, or time. When a runner speeds up or slows down, and is no longer moving at a constant velocity, they are accelerating. Our average acceleration is our change in velocity divided by our period, or change in time. Another key principle involves pendulums. When you think of pendulums, running isn't typically the first thing that comes to mind. But in reality, they're very relevant. We can think of our arms and legs as pendulums. Many associate fast runners with long legs, but this isn't always true. The period of a pendulum is 2 pi times the square root of the length of the pendulum divided by gravity. This means a runner with shorter legs and a shorter and faster period can run with the same velocity as a runner with longer legs and a slower and longer period. The final basic principle we should know is net force equals mass times acceleration. There are forces all around us, and in order for your body to be in equilibrium, the net force acting on our body must be zero. When we run, however, forces begin to act on different areas of the body. Friction also plays a key role in running, because it gives us what we commonly refer to as grip. Depending on your mass and your acceleration, these forces change and are exerted in different places. But what places exactly? Well, it depends on how you run and your form. And this sparks the question, what is the correct way to run? There are many varying opinions, but many of them lead us back to the barefoot running debate. So let's go running and see for ourselves. Is barefoot running the answer? With modern technology implemented into running shoes, cushioning and arch support are two things you'll commonly find in a shoe. However, proponents of barefoot running actually think these worsen our running form. You see, the problem is high arches and heel support put more cushioning on the heel. This means the runner wearing shoes can heel strike, or have the heel come in contact with the ground first. Heel striking leads to overstriding. When you overstride, you are in effect putting on the brakes with each step. By reaching out in front of your center of gravity, you are landing on your heel and stopping much of the forward momentum you've built up while running. An overstrider's foot is still moving forward as it hits the ground, so when it comes in contact with the ground, it actually causes the body to accelerate in a negative direction due to the heel exerting a force forward on the ground. Newton's third law tells us that the ground must exert an equal but opposite force back on the heel. Essentially, the heel is exerting a braking force. Therefore, your body must overcome this force, so it is actually more straining on your legs because they need to work harder. But when we run barefoot, our bodies naturally can't heel strike. The force exerted on the heel can be very painful because of the loss of the cushioned shoe compared to here. So our natural instincts cause us to turn to our forefoot up here. This is a much better form for our body because it brings our body more upright and it eliminates the force exerted on the heel. that the heel striker must overcome. It's far easier to accelerate when running on the forefoot. To avoid or correct overstriding, concentrate on landing on the ball of your foot, with your foot directly under your center of gravity. This will allow you to maintain most of your forward momentum. You should feel as if you're gliding smoothly along the ground with little impact or vertical motion. Impulse and momentum also play a key role here. If we rearrange the impulse momentum theorem, net force times the period equals the mass times your change in velocity, to net force equals your mass times your change in velocity divided by your period or change in time, we can see that the force exerted on the body is smaller if the period of contact by the foot is extended. A heel striker's foot comes in contact with the ground with a shorter and blunter period, which means the force exerted on the foot can be quite large. This is why we see lots of running injuries, especially in people who have more heel support in their shoes. Heel strikes apply an opposite force relative to the direction of motion, which also alters the runner's impulse and affects the momentum of the runner, and ultimately their speed. Forefoot running actually uses a bouncier approach, with a lighter step. This elongates the contact period of the foot with the ground, making the force exerted on the foot smaller. If you land on your forefoot, your foot will already have transitioned to moving backwards, so when it comes in contact with the ground, the force it exerts will be moving opposite relative to your direction. The equal and opposite force the ground exerts will then be exerted in the same direction relative to your motion, helping propel you forward. Once the angle in which your foot is applying the force is backwards and slightly downwards, then we are able to produce a propulsive impulse. It may also be important to remember that this extra acceleration during the propulsive phase of the stride can largely be attributed to the elasticity of our muscles. They store elastic potential energy. Some runners store this potential energy, typically sprinters, because they find it more useful to use small amount of braking force. Elite sprinters often land with their front foot only 6 centimeters in front of the knee upon foot-to-ground contact. This produces a small enough braking force to store potential energy for the propulsive phase. If you then observe an amateur sprinter, there is a tendency for the foot to land farther forward in front of the knee, producing a greater braking force. So now you know, and you're probably asking yourself, should I start barefoot running? Well, before you throw off your shoes, it's imperative to master the forefoot running form. It isn't just for any novice. Barefoot running takes practice and training to strengthen your muscles, and the transition won't happen overnight. But to start training yourself, try to take quick, shorter strides, landing on the ball of your foot when you run. When you stride, try not to let your foot land in front of your body. Increase your cadence and try to take 90 shorter strides per minute rather than elongated strides. If you fall below that level, you may be overstriding. No matter how you run, it's always great to get outside and get yourself moving. Thanks for watching and keep on running.